So now we focus on the training of the neural network. The question is, how can we optimize a large neural network? Let us, for example, consider this neural network with 3 hidden layers. First of all, we need to define a loss. We will see later on different types of losses. For now, we just need to assume that the loss is differentiable and its derivative is non-zero almost everywhere, which forbids us to choose the 0,1 loss function. One can, for example, use a square loss. Given this loss, our aim is to find parameters that minimize the empirical risk defined here, where f theta xi is a prediction of the network parameterized by theta at point xi. Once the loss is chosen, we would like to train the network by applying gradient descent procedure. Note that this prevents us from choosing an activation function which is piecewise constant. In that case, the gradient of the loss would be 0 almost everywhere. We will see in the sequel several activation functions satisfying this requirement. More precisely, we are going to use the stochastic gradient descent defined here. At each iteration, we randomly select a set I(t) of observations. Then you update theta, the vector of parameters of the network, with the following equation: theta t plus 1 equals theta t minus eta t times this expression, which is nothing but the average gradient of the loss with respect to the subset of points we've randomly chosen. You stop the updates when some stopping condition is satisfied. So we have almost everything to train our network. The only remaining problem is, how can we compute the gradient of the loss efficiently? This question was answered precisely for neural networks in 1986. The algorithm used to compute efficiently the gradient is called the backpropagation algorithm. The idea behind this algorithm is not new and can be traced back to Werbos in 1974. The idea is nothing but the chain rule with a touch of dynamic programming. Anyway, backpropagation is a key ingredient for neural networks to work in practice. Before 1986, it was not possible to train deep neural networks due mostly to the absence of backpropagation algorithms. Beware, as seen in the previous slide, backpropagation is not enough to train the network. The backpropagation algorithm allows us to compute the gradient of the loss efficiently, but this gradient is then used inside an optimization algorithm, any variant of gradient descent. So the backpropagation algorithm is not an optimization algorithm.